guys, I am ready for lesson 2 of module 15. I am on page 405 in your math workbooks. So make sure you have your math workbooks, make sure you have a pencil, and we will get started. So really quick before we start, I just wanted to remind you of the definition of a fraction, because that is very important to remember. When we write fractions, remember we talked about this yesterday, we use fractions to represent parts of a whole. So a whole can be divided into equal parts, and we use fractions to describe those parts. And how we describe them is with a numerator and a denominator. Sometimes we flip those numbers. It's important that we remember that the denominator goes on the bottom. One way that I remembered what goes on top and what goes on the bottom was that the denominator is downstairs. So if this is like a house, the denominator goes downstairs, right? Downstairs starts with a D, denominator starts with a D. So maybe that's a fun little trick for you to remember. And then of course the numerator is on top. The denominator is the total number of parts in one whole. So how many parts is the entire shape divided into? That is our denominator. And our numerator tells us the number of parts being counted. So just quick reminder of that. And let's go ahead and get started. So our I can statement says I can compare fractions that are divided into an equal number of same-sized parts. So if equal number of same-sized parts, those are, or that is the definition of our denominator. So I would just write that down, denominator. Of course, that's what our title of the lesson says, compare fractions with the same denominator. All right. The Spark Your Learning says, Ulan and Hector both like to read. Ulan has finished 3/8 of her book. Hector has finished 5/8 of the same book. Who has read more of the book? So now a really important thing to remember is that it specifies that they are reading the same book. And that is super important, that the wholes are the same. We talked about this with yesterday's lesson. We cannot compare parts of a whole if the wholes are different. Just like this example with the triangle and the circle. 1/2 of the triangle is going to cover a different amount of space than 1/2 of the circle. The fractions represent the same thing, right? They represent one part of two parts, but those areas are different because the area of the triangle is different than the area of a circle. So we have to be careful. We have to make sure that the wholes are the same. Okay, so they're the same book. So it says, who has read more of the book? That is the question I am trying to find. So I'm just comparing these numbers. Here we have a bar model of Ulan and Hector's books. So the denominator of both Ulan and Hector's books is 8, and that tells me that there are 8 equal parts. So I'm going to divide the bar models into 8 different parts. Now, since they are the same number of equal parts, they're both out of 8. To make things easy for me visually, I am going to draw the same line from Ulan all the way down to Hector. Okay, I'll show you what I mean. So I am going to divide this into 8 equal parts. I'm going to do my best to kind of space it out well. And instead of stopping at the bottom of Ulan's bar, I'm going to go all the way down to Hector because we have the same denominator. So I want to be able to quickly look at it and see, okay, which one is more. So I'm going to do that all the way until I have 8 sections. Okay. So not exactly perfect, but I just did my best. So Ulan has finished 3/8 of her book. So if each of these are 8s, I am going to color 3 of them. Okay, So this represents how much of the book Ulan has read. 3/8. Now I'm going to look at Hector. Hector has finished 5/8 of the book. So if each of these are eighths, I'm going to count 5 of them. 1, 2, 3, 4, 5. So now I have drawn my visual model, and it says, who has read more of the book? Well, to answer that question, I need to look and see how or who has more eighths filled out in their bar model. So if this was like a goal sheet or something, you know, where they're trying to keep track of how many pages they've read, we can see that Hector's covers more space. So we can say that Hector has read more pages. He has read more of the book. Okay? Awesome. Okay, the turn and talk says Jory has finished 4/8 of the same book. How does her reading compare with that of Ulan and Hector? So if Jory, I don't know if it's a he or a she, but if Jory finished 4/8 of the same book, it says her, how does her reading compare with that of Ulan and Hector? Well, since we have the same denominator, it's the same book, I would just count 1, 2, 3, 4 eighths. So she has read more than Ulan, but less than Hector, because 4 is in between 3 and 8. Pretty snazzy. Okay, next page. Build understanding. Number 1. Both Rennie and Leah paint same-size patios that are divided into 6 equal sections. Same-size patios, that is important. We can compare them because they're the same size patio. Rennie paints 3/6 of his patio floor orange. Leah paints 4/6 of her patio floor pink. Who paints less area? Part A says, how can you represent the areas that Rennie and Leah paint? So, Rennie, both, we have the same size patio going on here, and they are both divided into 6 equal sections. So I'm going to divide these patios into 6 equal sections, and since they're rectangles, I'm just going to divide it in half, and then into thirds. And I can do that because 2 times 3 equals 6 equal parts. Okay? All right. See where I got 2 times 3? 1, 2, 1, 2, 3. Good trick. Okay, so Rennie paints 3/6 of his patio floor orange. So I'm going to fill in 3 of the 6 parts. Okay? So that is orange. And then Leah paints 4/6 of her patio pink. So I'm going to color in 4 of the equal parts. 1, 2, 3, 4. Okay? So part B says, who paints less area of the patio? How do you know? Well, just by looking at it, Rennie's paint covers less area. So Rennie painted less because he only painted 3 parts and Leah painted 4. And we know that 4 is more than 3. And we can confidently say that because the patios are exactly the same and they are divided into the same number of equal parts. So basically what we're saying, you guys, is when the denominators are the same, we just look at the numerator as long as we're referring to the same whole thing. Since the patios are the same size and the denominators are the same size, we can look at our numerator and be like, oh, 3 is obviously less than 4. Okay? So it says, write less than, greater than, or equal to. And this is something that I am a little bit particular about, is how you guys read this little thing right here. How you read it. I want you to read it like a sentence, and I want you to start with the first fraction shown. Anytime you see something like this, start with the first number, just like we're reading a book. We start with 3/6. We do not just jump to whatever is greater, because that's not always the case. We can't just flip it and say, oh, it's greater than. Use a greater than symbol, because that's not what we're doing. We're saying 3/6 is either greater than, less than, or equal to 4/6. Okay, so keep it in that order, and that's why you guys need to memorize these symbols, right? So you know which one would make sense in that number sentence. So 3/6 is, we just determined that 3/6 is less than 4/6. So I am going to put the less than symbol there. And remember how it's kind of like an L, but like a little turned? Okay. Number 2 says, Ellen's desk is 7/4 yards from the wall. Ethan's desk is 3/4 yard from the wall. Part A says, how can you show each distance using fraction strips and a number line? So I'm going to represent how far away Ellen's desk is on this fraction strip here, okay? It's kind of like a bar model. So 7/4, this one's kind of tricky because the numerator is a bigger number than the denominator. All that means is we are still counting. There are 4 equal parts in one whole. In this case, the whole is a yard. So we are taking 1 yard, dividing it into 4 equal sections, and we are just counting 7 of those equal sections. So we're obviously going to be more than 1 yard, because 7 is more than 4. So we'll just go here. It's divided into fourths, so I'm just going to color in 7 of them. 1, 2, 3, 4, 5, 6, 7. Okay, if we wanted to be superstar students, we could say, I'm going to split up right here. 1, 2, 3, 4 fourths is 1 full yard. So 7/4 is the same as 1, and 1, 2, 3 fourths. That's a mixed number. Do you guys remember that from Module 13? Cool, cool. Okay. Now, Ethan's desk is 3/4 from the yard, so I'm just going to count 3 of the fourths. Ta-da! Now it says to use a number line. So on the number line, I'm doing the same thing, but I'm going to mark both of them on the same line. So as you can see, the number line is divided into fourths. Up top, we have our whole numbers, 0, 1, 2, and then on the bottom, we have our fractions. 0/4, 4/4, which you'll notice is the same as 1 whole, and 8/4, which you'll notice is the same as 2 wholes. So I'm going to count 7/4 to mark Ellen's desk. There's 0, 1, 2, 3, 4, 5, 6, 7. Draw a dot. Ethan's is 3/4, so I'm going to count that 0, 1, 2, 3. Draw a dot. Okay, so which one is further from the wall? And how do you know? Well, if we look at our number line, if this is the wall right here at 0, 7/4 is a lot farther away than 3/4. Same with on our fraction strip. So Ellen's desk is farther away because 7/4, over here, 7/4 is greater than 3/4. Okay. Awesome, awesome. Okay, the turn-in talk says, what is a quick way to find out which fraction is greater if both fractions have the same denominator? We kind of already talked about this when we talked about Rennie and Leah's patio. We said If the wholes are the same, so the patio is the same, if the denominators are the same, just look at the numerator and see which one is bigger. Pretty easy. Number 3 on our Step It Out, it says, Len uses 5/8 of a wooden board to make a roof for a tree house. Raylette, that's a pretty name, Raylette uses 7/8 of a same size board to make a chair. That's important, same size board, so we can compare these fractions. Who uses more of their board? Show where Len and Raylette cut their boards. Part A says, when equal-sized wholes are divided into the same number of equal parts, the denominators are the same. You can then look at the blank to compare the number of parts being counted. Well, that's our definition right here. Number of parts being counted. Is that ringing any bells? Is anyone screaming? Oh my gosh, I know what that is. Look at our whiteboard. Where did it go? Parts being counted. That is our numerator. Yay. Okay. So you can look at the numerator to compare the number of parts being counted. So Len uses 5/8 of the wooden board. So he uses 1, 2, 3, 4, 5. Raylette uses 7/8 of the same size board. 1, 2, 3, 4, 5, 6, 7. Yay! Okay, so each whole board has 8 equal parts. We know that because the denominators are the same. Now it says compare the numerators. Blank parts are more than blank parts. So what's more, 7 or 5? 7 parts are more than 5 parts. Oop. Lost my book. So what would I put in this in the blanks to make this make sense? If this is a greater than sign, I want the greater number here. 7 is greater than 5, so 7/8 is greater than 5/8. Yay! So who uses more of their board? Raylette. To compare fractions with the same denominator, how do the numerators tell you which fraction is greater? Well, how does it tell you? We've talked about this a lot. To compare fractions with the same denominator, how do the numerators tell you which fraction is bigger? Well, the fraction with the bigger numerator has more parts being counted. That was not my best handwriting. Don't do what I did. Do nice handwriting. Okay, let's do our check understanding. It says on Tuesday it rains 3/4 of an inch. Oh my gosh, this is perfect. This perfectly ties in with what you guys are doing in science right now. Right now you guys are measuring your rain gauges and measuring how much it rains. That is so fun. Okay, on Tuesday it rains 3/4 of an inch. On Wednesday it rains 2/4 of an inch. On which day is there more rain? Draw a visual model to justify your answer. So, in order to draw a visual model, I need to know what the whole is. We are talking about inches. So I am going to draw 1 inch. I'm just going to do a rectangle about the size of an inch. That might be too big, but that's okay. And then I'm going to draw another bar right next to it so I can compare them. Same size. Now I'm going to divide those inches into fourths because my denominator is 4. So I have 4 equal parts. Make sure they're lined up. Okay. On Tuesday, T for Tuesday, it rains 3/4 of an inch. 1, 2, 3. On Wednesday, W for Wednesday, it rains 2/4 of an inch. 1, 2. So on which day is there more rain? Well, I drew my visual model, so I can say, oh, Tuesday's bar model shows more than Wednesday's. Or I could also say 3 is greater than 2, so 3/4 is greater than 2/4. So the answer is Tuesday. Oh gosh, I almost said Wednesday. The answer is Tuesday. Awesome. All right, for the on your own, it says, Lisa has 2 same-sized pizzas. She says 3/8 of one pizza is greater than 5/8 of the other because each of the 3 equal parts in 3/8 is larger than each of the 5 equal parts of 5/8. Is Lisa correct? Explain your answer and draw a visual model to show your reasoning. Okay, I think right off the bat we're like, Lisa, what are you talking about? So let's just, for the sake of argument, we'll draw this out. So she has 2 same-sized pizzas. 2 same-sized pizzas. So they're the same whole, so we can compare them. Both of them are divided into 8 equal parts. So I'm going to divide these circles into 8 equal parts. Watch how I do this. I do a plus sign in the circle first, like that, and then I do an X, cutting it in half. Okay, doing the best that I can. Same pizzas, same size slices, because they're the same number of denominators. So she says 3/8 of one pizza, so I'm going to shade in 3 parts, is greater than 5/8 of the other pizza. So I'm going to shade in 5 parts. She says that 3/8 of one pizza is greater than 5/8 of the other pizza because each of the 3 equal parts in 3/8 is larger than each of the 5 equal parts in 5/8. Is Lisa correct? No way. Look at our visual model. Same size pizza, same number of equal parts, so we can trust our visual model. 5 is more than 3. There's just no doubt about it. If this pizza right here, that was, we shaded 3 out of 8, maybe if it was a giant pizza, okay, then yes, probably that slice is gonna be bigger than the other pizza. But that's not the situation. We have the same exact size of pizzas, so the slices are exactly the same. So we can compare the numerators and say, no, Lisa, 5 is greater than 3, which means 5/8 is greater than 3/8. And then she'll say, oh, you're right. So write that all down for number 2. Okay, now I'm at number 3, where it says compare the fractions. Write less than, greater than, or equal to. Okay, so remember, read this like a number sentence. Start with the first fraction first. 3/8 is blank than 5/8. Oh, that's just like our pizzas. 3/8 is less than 5/8. Do you see how I didn't switch it and say 5/8 is greater than 3/8? It is a true fact, 5/8 is greater than 3/8, but is that what my problem says? No, my problem is starting with 3/8, so I'm going to use the proper vocabulary. 3/8 is less than 5/8. Okay, number 4, 5/6 is blank than 4/6. 5 is more than 4, so 5/6 is greater than 4/6. And number 5. 5/3 is blank than 5/3. Those are the same. So we'll use an equal sign. Remember, equal sign means equal to or the same as. 5/3 is the same as 5/3. Awesome. Okay, number 6. Remy's family eats 2/6 of a carrot loaf and 3/6 of a pumpkin loaf. Both loaves are the same size, so we can compare them. They're the same size. Which loaf has less left over? Explain. Less left over. So basically, another way of saying this is kind of a double negative, which is hard to like wrap our brain around sometimes. Instead of saying which loaf has less left over, we could say which loaf did more people eat. And so we can just compare 2/6 of the carrot loaf, 3/6 of the pumpkin loaf, which loaf had more eaten. Well, since we have the same denominator, 6, and the loaves are the same size, we can just look at the numerator. So 2 and 3. 3 is greater than 2, so more of the pumpkin loaf was eaten, so that means there's less left over. So you'll write that all out right here. All right. So that is all for lesson 2. Let me know if you have any questions. Get your math homework done. Practice as much as you can. And like I said, if you need anything, let me know. I'll talk to you later. Bye.